I guess that many of you are not familiar with the term Fab Lab. Do I guess correctly? Thank you. I'll briefly tell you what a Fab Lab is. A Fab Lab is a lab, a laboratory, and Fab stands for fabrication. So think of some kind of mini manufacturing plant where you will find many traditional manufacturing machines like CNC mills, like 3D printers, like laser cutters. The Fab Labs started some 10 years or so ago. There's a project at MIT in the US that's called the Center for Bits and Atoms. Professor Neil Gershenfeld is trying to find ways how to deal with atoms in a way how we can now deal with bits. That's a big research project, many years. And in the context of this research project, he started to collect all sorts of manufacturing machines and then made those, or a few of those manufacturing machines, available to his students in a course called How to Make Almost Anything. And he was thinking that this course would particularly attract engineers and maybe computer scientists. And he was completely surprised when the course attracted artists and designers. He then was required to do some outreach activity. And professors normally write a book or set up a website when they do that. He did write a book. He has some kind of website. But he also founded a first fabrication laboratory in inner city Boston to give ordinary people in a deprived area access to digital manufacturing technology. And then something really crazy happened. The whole planet wanted to have such labs. And in the past 10 years, the number of such fab labs has grown from one or a few that MIT has set up to over 300 labs globally. These are 300 labs globally that give ordinary people that don't have an engineering degree, like artists, like designers, like inventors, access to digital manufacturing technology and access to 3D printers. I have to clarify something about 3D printers now. We've seen all those very interesting examples, thankfully, from Materialize this morning, and the range of materials that can be used in 3D printing. We even heard about bio 3D printing. This is not what's done in Fab Labs. In Fab Labs, these are very basic machines, the ones that have been addressed as home printers that cost you a few hundred or a few thousand euros. And they typically use one material, some kind of plastic. The same material that your Lego bricks are made from, ABS. Or maybe PLA. We heard this word this afternoon as well. Now, I'm an industrial engineer by training. So I have learned how to run a factory. I've studied that, and I've written a PhD about that. And I'm now involved in these fab labs, these microfactories that attract all sorts of weird people who want to make their own things. And this is the complete opposite to what I wrote about in my PhD. The complete opposite. And not only the complete opposite because ordinary people get access to these machines. We're used to those. And with those, we make movies. Think back some 50 years, what it took a hobbyist to make a movie. And the Fab Labs are there for manufacturing today what hobbyist film cameras have been 50 years ago. one thing I need to mention. I know how to organize a factory, but these labs don't operate as a factory. These labs form some kind of global network. And of course, there is Professor Gershenfeld and his crew, sort of the inventors of the idea behind it. But there is no central control of the Fab Lab network. When people ask me, how do we become a Fab Lab? Do we have to fulfill certain criteria? Or do we have to buy a franchise? Or do we have to go through expensive training? There is some training available. There is some sort of accreditation. But basically, anybody who opens such a workshop and wants to be part of the network and wants to give people access to manufacturing technology can be a Fab Lab. And this is a completely weird idea for everybody who is involved in traditional organizations, traditional institutions, and traditional policy making. Now, this was a very long introduction to explain you where I'm coming from when I'm speaking about 3D printing challenges and threats. And I'd like to address that on sort of 3 levels. One is particularly speaking about the topic of today, the policy making around 3D printing. As this Fab Lab environment is a global network with very little central structure, we incur a lot of troubles with national legislation. We talk across the globe, but what you can do with something that is patented in the US compared to here is different. What can be under copyright in Italy is different to what is under copyright in Germany. This makes it extremely difficult to explain to those lay people what copyright patents are about. When we talk about EU directives, probably 99% of our people that work in Fab Labs have never heard of EU directives, or wouldn't know where to start looking for them. Or if they would find one of those websites that explain EU directives, they will quickly walk away and say, that's much too complicated. I'd rather play with my 3D printer. It's much easier. I'm very happy to hear about international agreements and standards, because that makes one thing so much easier, is educating people. And that's one of the core tasks of Fab Labs, to educate people about manufacturing in a different way than traditional education works. And let me make a footnote here. I think it's important to train engineers and to educate professionals on 3D printing. This is a long way. We need everybody to basically understand what 3D printing is and what it can do and what it cannot do. And I don't want to wait 20 years until we've all got those engineers. So I think exposing people to a basic 3D printing technology is a quick way to turn that around. When we think about legislation in this Fab Lab context, we're all very much about sharing an open source, which many people think is the complete opposite of IP protection. I would say no. Open source is exactly a strategy to deal with intellectual property, as is patenting or copyright. So I think that new technology does not require necessarily new legislation. We had this in the first session this afternoon, thankfully confirmed. I think that we don't need to regulate technology, but use of technology, as the gun example really shows. And this has led to a lot of discussions in the Fab Lab community. How do we deal with that apparent threat? But we were quickly in reflecting that when you've got a workshop where you can make almost anything, obviously you have to think about people doing bad things. And we have as a community to regulate that. I would advocate to think about balance when making policy and creating legislation. When we're thinking about protection, who do we want to protect? And from what or from whom? Is it individuals who we protect? Is it public goods that we protect? Or is it the commons, common knowledge, access to knowledge? And as a teaser at the end, commercial interests. Why do we need legislation to protect them? Thank you very much.